All right, let's get into this. We're going to talk about a technology that could totally change how we think about our cities and the air we breathe.
Yeah, you heard that right.
We're talking about roads that can literally eat smog.
I know, it sounds a little bit like science fiction, doesn't it? I mean, we build our cities by paving over nature, but what if the very concrete we lay down could actually start to act like a forest, cleaning the air around it? What if our own infrastructure could start fighting back against pollution for us?
Because let's be real, this scene right here is the daily reality for millions of people. This is Highway 401 in Toronto. It's one of the busiest highways in the world, with over 340,000 vehicles passing through every single day. And every one of those cars is pumping out pollutants, especially stuff like nitrogen oxides, or NOx, which are just awful for our health and for the environment.
But what if we could flip the script? What if we could turn this massive problem into part of the solution? Well, that is the incredible promise of something called photocatalysis. It's a way to make our roads and highway barriers actively scrub the air clean. And get this, it's powered by nothing more than sunlight.
Okay, so how on earth does this actually work? Let's break down the science. It's actually pretty cool.
So at its heart, photocatalysis is just a chemical reaction that gets kicked into gear by light. You take a surface, you coat it with a special material, that's your photocatalyst, and when sunlight hits it, it gets all energized and basically starts attacking and breaking down any pollutants that happen to touch. Now, the classic material for this is a compound called titanium dioxide, or TiO2. So imagine a highway barrier coated in this stuff. When the UV light from the sun hits it, the surface becomes super reactive. As the nasty NOx from car exhaust floats by, it gets zapped, captured, and oxidized. It's essentially torn apart and reformed into different, less harmful things. Now, the idea itself is brilliant, right? And it got a lot of people really excited. Cities all over the world, from Manila to Germany, started coating roads and sound barriers with TiO2. But this is where the story takes a turn, because the real world, as it often does, had other plans. And, this quote from the research really sums it up perfectly. What worked like a charm in the lab just wasn't cutting it out on the streets. In some of these huge, real-world tests, the actual reduction in pollution was tiny, sometimes as low as 2%. It was a massive disappointment. So what went wrong?
Well, it turns out it wasn't just one thing. It was a whole bunch of critical flaws. First off, aerodynamics. Think about it. The polluted air just flows right over a flat barrier. Most of it never even touched the smog-eating surface. Problem two, the chemical reaction itself could actually create new nasty byproducts, like formaldehyde or even more smog-producing ozone. Not good. Third, over time, the surface would get clogged with nitrate salts, forming this hard scale that basically turned the coating off. And finally, TiO2 only gets activated by UV light, and that's just a tiny sliver, only 4% of the sun's total energy. So it was incredibly inefficient. And you can really see that byproduct problem here. On the left, the old process could create those harmful nitrates, but the new approach on the right, it uses a much cleaner reaction that turns that dangerous NOx back into simple, harmless nitrogen and oxygen, the stuff that makes up most of the air we breathe anyway. It's just a much, much safer way to do it. So all of this sent researchers straight back to the drawing board. They knew they had to fix two big things at the same time: the physical shape of the barrier and the actual chemistry of the coating itself.
Okay, so first the physical design. This is so clever. Instead of just a flat wall, they came up with this double wall barrier. See that angled piece on top? It's not just for looks. It actually grabs the dirty air swirling up from traffic and forces it down into the channel between the two walls. This means the air has to make contact with the catalyst-coated surface inside. It completely solves that airflow problem. And it's totally passive. No fans, no electricity, just really smart physics. And then there's the new chemistry. This chart really lays it out. This new smog stop coating uses that cleaner reduction reaction. So instead of harmful byproducts, you get harmless nitrogen and oxygen gas. Instead of just using UV light, it uses both UV and the visible light spectrum, making it way more efficient. And maybe most importantly, it doesn't form that crusty scale, so it keeps on working year after year.
And the lab results? Well, they really speak for themselves. This chart shows a direct head-to-head battle. That big purple bar on the right, that's the new smog stop catalyst, and it just blows the standard TiO2 out of the water. Overall, the new coating proved to be 3.6 times more efficient in the lab. But of course, the million-dollar question is, does it actually work on a real highway?
Because, lab tests are one thing, but to really prove this works, you've got to take it out into the wild. You have to put it up against the toughest challenge you can find.
And that's exactly what they did. They installed a 15-meter section of this new barrier right alongside the busiest highway in North America, Highway 401. They put sensors everywhere, measuring pollution levels going in and coming out, and they just let it run for 6 months, through sun, rain, snow, road salt, you name it. So what happened? The results were staggering. During the day, the barrier reduced nitrogen oxide levels by an average of 49%. Remember those old tests that were getting like 2%? This is 49, a night and day difference. But hold on, it gets even better. During the sunniest parts of the day, when the catalyst was really humming, the pollution reduction hit a peak of 92%. That's almost complete removal of the harmful NOx from the air passing through that barrier. Just wow. Let me put that number into perspective for you. If you built just 1 kilometer of this barrier, it would remove the same amount of pollution as taking 200,000 cars off that piece of road every single day. That is an absolute game changer. And a success like this didn't just happen overnight. This timeline shows it was a long journey, starting with that first concept back in 2011, going through wind tunnel tests, years of developing the chemistry, all leading up to that incredible field test in 2018. It's just a great example of solving a really complex problem by attacking it from every single angle. Which kind of brings us full circle, back to that first question we asked. For decades, we've just accepted that roads are a source of pollution, a necessary evil we had to live with. But this technology points to a totally different future. A future where the very infrastructure that makes up our cities could actually help them to breathe again. So, what do you think? Could this really be the urban forest of the future?